Hello, Engineer Kunle.
Hello, good morning, everybody.
All right, good morning, Engineer Kunle.
Can you hear me?
Yes, go ahead, we can hear you.
Okay, we are all welcome on board. As we have been briefed, the topic is common inverters and solution to them. Common inverter problems and solution to them. Now, let me go straight. Now, the first one here is inverter not turning on. And it may sound so simple, but then if you get to your inverter, maybe it's been working, just stop, doesn't come on. Then things you can check the power supply, wiring, and the connections. You know, something may be responsible to it. Maybe the batteries is dead at the end of the day, caused by something. So when you check all things around the inverter, then you try it again. You ensure input voltage is within range, because if the input voltage is out of range, the inverter may not support it, while the battery will drain eventually, and the system will shut down and it won't come up because it's not charged. Then replace fuses or reset circuit breaker if the circuit breaker has tripped. For instance, now you have a solar breaker tripped, you have utility supply breaker tripped, and then by the time you drain the battery, the system will shut down. So those are the simple things you need to check when your inverter is not coming up. Then you have another condition or situation, no output. When you don't have output from your inverter system, then you check the solar panels, ensure they are clean, not shaded, and they are producing power. You know, you have your meters to check the voltage in there close to the inverter. Do you have a voltage from the solar? You know, if you have voltage, then it may not be enough when the inverter is now running if there is a shade on it, because you may be reading just VOC, open circuit voltage, and open circuit voltage, when it's not connected to deliver power, is nothing. So that's why you need to make sure that there is no shade on the solar panels, is clean, and everything up with it is okay. Then inspect wiring. Look for loose or damaged connections or components between panels, inverter, and the charge controllers. Because if there's a failure, then it won't get to the inverter. And then if it's not getting to the inverter, it may not get any output. So verify inverter settings. Yeah, your inverter may be displaying. You see that it shows the screen is on, but then it's not giving output. So ensure it's turned on and configured correctly. Because settings inside all this inverter matters a lot. If you tell your inverter that you should not give output when utility is available, whatever you will give as instruction is what it's going to do. If you tell your inverter that, oh, inverter, when you see so capacity of load shut down, that is exactly what it's going to do. So configuration of the inverter is crucial, is very, very important. So check circuit breakers, make sure it hasn't tripped. Because if the inverter is showing that it's displaying, and you're not getting power into your building, probably the output breaker is tripped off. Then when you have inverter producing distorted output, and maybe just come up, it goes off again, or it just flashes, then you check input voltage quality. This is also very important. If the quality of power supply into the inverter is not acceptable, it will not give you the expected output. So, like for the frequency, the voltage, they need to be acceptable by the inverter. Ensure output filter is properly configured. This boils out to the configuration inside the inverter. Like I said, is what you tell your inverter to do that is going to do. If you change the frequency of your inverter to 60 Hz and what we use here is 50 Hz, it's not going to support it. You understand? So adjust output voltage and frequency settings. That is if it's necessary. Other settings may even hinder the inverter to give distorted output. For some inverter that have a capacity setting, that okay, you don't want your battery to get damaged, so you want to use the capacity settings to protect your battery from being overloaded. When they overload it, it's going to shut down and then come up again because it's having automatic shut down and come up. So after some seconds, it will just come up. But if you tell the inverter that, oh, when you shut down, just shut down permanently, it will shut down and wait until you go there to restart it yourself. So all these settings matter, like I mentioned before. Reduced output. When you have reduced output from the inverter, monitor solar panels performance. Check for shading, deaths, or damaged components or links. Now, where that comes to play is, for instance, you have a system that is batteryless. The way batteryless inverter behave, when the solar power is going down because of generation, solar energy generated that is going down, the output voltage too will be going down within a range. If you discover that instead of you having 230, you are now having 200, it may not shut down at that time. But because it's batteryless, there is no reserve for it to just peak from. When the sun is going down, you will see that the output will go down. It will get to a point to shut down. So you need to, that's why you need to be sure that the solar panel is generating well. Inspect inverter efficiency. That's you need to ensure it's operating within optimal temperature range. Temperature can make the inverter to misbehave. It may even shut down on temperature. High temperature, it will just shut down. So verify load. If your load is excessive, then it will shut down. And if you have programmed that, oh, inverter, when you shut down on overload, after a few seconds, sample the load again and see whether it's there. If it's not there, come up and power the load. It will do the same thing. So when you verify your load, if the load is excessive, then you can reduce it. That's why you need components that will not make your inverter to be overloaded, like a properly sized circuit breakers or power limiter at the output of the inverter, so that your inverter works seamlessly. You don't even experience any overload when you have a proper sizing of protective devices around the inverter. Now, check battery condition. For hybrid system, a weak battery can impact inverter performance. When the battery is weak and you load it, it will shut down on low battery. And then if it's based on the settings that is inside it, it may still come up again. And then it will go off. If your load is so heavy to push it to that low battery and shut down, when the load is off it, the inverter will see that the voltage is up. So it will come up again. But if the battery is bad, sulfated, it will be doing the same thing. So you need to test the battery properly and be sure what the condition of the battery is. Overheating is another problem. And this, your inverter can show temperature, a code. So you can just shut down. If you don't get there to the inverter stand and see what is on the display screen, you may not know exactly why the inverter shut down, but it could be overheating. And so what you need to do in case of such problem is improve ventilation. Ensure the inverter is installed in a well-ventilated area. Clean regularly, because dust is a serious case when it comes to ventilation. If dust accumulates on the vents, the holes that are on the inverter, and does not allow fresh air to go in to cool the components, then the inverter will develop over temperature and it will shut down. Check performance of cooling fans. If the fans are not working well, when the inverter is loaded or when it's charging heavily, it will definitely rise in temperature and then it will shut down. Check ambient temperature that around that place. Is the place so hot? So if the place is not cool and not conducive for inverter, then you have to either relocate it or put cooling systems around that place. That's why you see in a big for a big system installation, you are required to keep the system with air conditioner. In some places, you need to put external fans just to make sure that the temperature, ambient temperature is acceptable. Inverter not charging battery is another problem. Check the utility supply voltage level and frequency. If they are not acceptable, maybe you are using a generator that the frequency keeps dancing up and down. The inverter, all these inverters now, they are very sensitive to that. They will not accept it. If the frequency is not stable within a range, it will not accept it. And when it doesn't accept it, it will not charge. That's in terms of the utility supply. Now, check the solar input voltage. If the circuit breaker for the solar is stripped and they are not getting anything from the roof, or based on another problem from solar energy, then it won't charge, because those are the two main charging sources, the utility and the solar. If they are not available, then the batteries will not charge. Check charging settings and parameters. This is also very important. If you don't program your inverter properly, it will not charge. Because it's possible to instruct the inverter that, oh, charge with only utility, don't charge with solar, or charge with only solar, don't charge with utility, or charge with both of them, or don't charge with any of them. I just want to be using it. So it depends on how your inverter was designed, and then what instruction you have given through your configuration parameter setting. So it's very important. Ensure battery is properly connected. If your batteries are not connected properly, it will affect the charging too, because they won't charge well. And then the batteries will get damaged at the end of the day. Check for battery damage or age. Because when batteries are aged, when they are old, they tend not to accept charge and they don't give out what they don't have. You see, the backup time must have reduced, and then they will quickly charge up and tell you battery full. So that's it. Now, we have some error codes that are so common that you can interpret yourself. Well, you need to lay your hands on the manual. If you are an installer or you are the end user, it's still very important that you have an idea of what's going on with your system. So that's why each system is provided with a user manual, so that when it happens, you can check yourself, oh, this is what is happening. You may not even need to call your installer if you are an end user. Once you know what is happening, you solve the problem yourself. But if it's beyond you, then you get across to your installer. If it's not what installer can do, then it goes beyond that, then gets to the next level, maybe the supplier. But consult manual, we need to read. Understand the specific error code and its meaning. For instance, O4 means low battery for some inverter. O2, especially Gennex inverter. O2 means over temperature. So you need to look around. What's causing over temperature? If it is low battery, by the time you see the code there flashing, you know that, oh, since how many days now we did not have a utility supply, or the weather has been so bad, there has been poor generation from the solar panels. So you won't need to panic that, oh, the inverter wants to break down or something wants to happen. Then O7 is overload. Once you allow the inverter to be overloaded, it will show O7 down and shut down. But if you don't allow that, maybe you size your protective devices properly, then the protective devices are the ones that will check for overload, like circuit breaker, power limiter. They'll just strip off. The inverter will not even know what happened. Then when such a thing happens, you go there and trip them on, reduce your load, and you are good to go. Troubleshoot based on code. Follow manufacturer guidelines. So contact support. If unable to resolve, reach out to the inverter supplier. It's very important. When you reach out to your supplier, they know what to do. They'll get you, at least they'll get the problem resolved for you. Now, frequent shutdown. When your inverter shuts down frequently, check for overloading, reduce power consumption, or upgrade the inverter. If you have too much than what the inverter capacity can conveniently power, then you need to upgrade your system. Inspect ground faults. Address any electrical ground issues, because it may be shutting down based on leakage, based on improper earthing condition. So please, it's very important. Don't let us just look at it and once I just hang my inverter, it's not connected to earthing and it's good to go. It's not going to shock anybody. And then if your solar cable is leaking, that's why we develop how to test for leakage in your solar panel. And then you check if your earthing is proper, because they can make your inverter come up, go off, come up, go off, and then eventually the inverter will get damaged. Now, verify inverter setting, because that one too can cause it. Like I've been emphasizing on the other point, is important. Make sure you program your inverter very well. So we have some common inverter problems as related to solar panels, because the inverter is the one that interfaces to your load. If anything happens to other things connected to the inverter, by the time the inverter will react, it may shut down. When it shuts down, that's when the owner will now know, oh, there's something going on. Or when there is a noise, alarm, oh, something is going on, you now need to go close to it. So it could be utility supply, it could be solar. Now, we are talking about those that are related to solar panel. If your panels are dirty, you won't get enough energy from the solar, and then this can be a problem. So clean panels, remove dirt, bed droppings, or leaves from the panels to make them generate properly. Check for shading, trim trees, or relocate objects blocking sunlight from getting contact directly with the solar panel. Inspect for damage. Repair or replace damaged panels. Monitor temperature. High temperatures can reduce efficiency. So professional maintenance, you need to seek expert assistance for complex issues. It's important to carry out maintenance on your system, especially when they are just dirty. For instance, solar panels are dirty, you don't clean them. It's not going to give you optimum performance. Now, we have additional tips. Regular maintenance, just like I just said, is very important. Conduct routine check on all system components, not only on solar panel or the inverter, all the breakers that are there, the other components, every component that is surrounding, check. Batteries, cables, terminals, it's very important. Monitor performance. Use inverter monitoring tools to track systems health. You can be in your house. You can check your client's inverter to see how it's performing. Days back, since installation, all this monitoring system, they keep the information there for you. You can check. Maybe they are having overload, they are having low battery, whatever the things, you can see through the monitoring system. You'll be able to spot it and tell them what they are doing. If they are doing something wrong, you'll be able to let them know so that they change. And then both parties will be at peace. Professional installation. It's required that you do a professional installation. Ensure proper installation by qualified technicians, not just people that will just twist cable. Some people will just cut solar cables, they just twist it together, and then at the end of the day, they'll be to start causing issues. See, please, it's very important. I'm not saying you cannot join cables. There are professional ways of joining cable. And then these panels are being equipped with connectors. So we should plug them professionally, make it neat, easy for troubleshooting, easy for maintenance and others. So it's very important. Quality components. Invest in reliable inverter and solar panels and other components as well, not just inverters and solar panels. If you have a substandard circuit breaker, it's going to run you into trouble because you have done installation and then they call, maybe it's far, all the way from Kano or Maiduguri, and you are in Lagos, they call you, it's tripping. So, you know, you may lose recommendation if you don't invest in a quality component. Backup power. Now, consider battery backup for uninterrupted power supply. Because some people will say, yes, I want a batteryless system. Batteryless system does not have battery. And then you don't have any backup. So it's definitely going to be interrupted. Once the weather goes bad, or you have overload that you don't have enough solar panel and the weather goes bad, it's going to shut down. If it's utility that is available and is running on batteryless, when utility goes and the solar cannot power it, cannot sustain it, it's going to shut down. So all these are very important. Thank you.
Thank you, Engineer Kule, for that wonderful and impactful session. Now, I got to know, and others too, that when you have error 07 or your inverter, you shouldn't retrieve and bring to the office. Imagine a lot of persons that have done that. Consider the cost of sending the inverter and the kind of things that the client will have in mind towards you. They will think maybe you are not professional enough. So once you see error 07, you will know that, oh, this one is overload. Then again, under the reduced output, Engineer Akule talked about batteryless. People will be wondering, to some people, they don't know that some inverters can work without battery. If you really want to know about this, visit Gennex, because Gennex has series of inverters that can work without battery. The likes of MKS3, 5 kVA, 8 kVA twin, grow at 5 kVA and 6 kVA. But you need more information about this. So you can visit our office or you call any of us. So it is time for question and answers. If you have a question or two that you want to ask the facilitator, you can just signify why the host allows you to talk. And then if you can't make use of that, you can use the chat box to send your question and it will be treated. So we want questions that are relevant this time. You can go ahead with your question. Okay, so before the question, I think we have the executive director of this company, Gennex Technologies. That is the person of Mrs. Tony Ilo. I think it's a privilege she's on this conversation. Thank you for joining, ma. All right, so it is time for questions, please.
Hello, thank you, Adam. And thank you, Kunle, for the wonderful and insightful presentation. I think going by this, the common issues surrounding our inverters usage will be curtailed to a very large extent. Thank you for participating. Yeah, we can go ahead, please.
Okay. All right, Engineer Kule, are you with me? So there's a question here. You made mention of checking efficiency of inverter. How do you go about it? Or tools required to do that? So someone is asking how to check for inverter's efficiency and the tools that can be used to do that.
Yeah, efficiency of inverters are given by the manufacturer. How like, you know, before now, Gennex inverter was if you see 3 kVA, the capacity in watts will be lesser. But now the efficiency has increased. It's always stated in the manual, in the specifications of the inverter. So you know that, oh, this is the efficiency of this capacity or this model or this size of inverter. It's always stated. You put it as part of the specification. So it's not something that you need to measure, unless if you don't want to, you just want to be doing research on what they have done. Because these are finished products and they have the standard equipment in the laboratory, in the factory. They have tested everything before pushing them out. So it's just for you to know that, okay, my inverter, oh, this is what I'm expecting from it. And they have stated them. Like, okay, the frequency of operation is so hertz. Is so you can change it to so hertz, 50 hertz, or you change it to 60 hertz. But what we use in Nigeria is, so all those informations are stated, clearly stated in the specification sheet.
Okay, thank you, Engineer Kule. I believe the person that asked the question is cleared now. So another one says, one of my challenges is error 08. That is high bus voltage rather. Apart from batteries issues, what else could be the cause and how can we avoid it?
Well, 08 I know it's a major problem. It's a major when it pops up, saying high bus bar, high bus this. Well, many errors can come up on these inverters, and they are related to other things. That's why I emphasize more on earthing and leakages. Once you have checked everything surrounded the inverter to be okay, you have tightened the battery terminal well, you have connected the solar cable using all components carefully and correctly, and you have a problem, then we can look inward that, oh, this problem is internal. It's not something that happens like in all inverter. A problem, any equipment can develop a problem. So once that happens, then the system has to be taken for check in the repair center or service center. But once everything is okay, there's no problem.
Hello, good morning.
Yeah, good morning.
Yeah. First and foremost, I would like to thank the host and the person that trained us. We really appreciate this training. But what I would like to ask, if it is possible, a slide of this training so that it will be a reference for us to go back after this Zoom meeting, so that we can go through it and read deeply, if it is possible. Please. Hello.
Okay, so Magmos technology, Maxim,
Yes.
right?
Yes, you are right.
Okay, so the slide will be shared with you people.
Thank you, sir.
Is that all?
Yes, sir.
Okay. All right, there's a question for Engineer Kule here. Can error 05 be corrected by itself after clearing the faults of the short circuit in the house wiring?
Yes. Error 05 can disappear once the external causes are removed. That is, if the 05 was caused by the external problem, external maybe cables or error. But if it is internal, then, like I said, any component can fail. And if it's internal due to error that was caused from outside and is now permanent, then the system has to go for maintenance or repair. But if it's just short circuit based on external, it could be intermittent. It just happened. Once you clear the problem, then the inverter will continue to work.
I think there's a question from Total Logic. Total Logic, your question, please.
Okay. Good morning, sir. Yeah, you have answered my question, but the other one that came through my mind was that if at all the both live and neutral of the inverter is coming on with tester, I mean, there's a light, there's a footage on the both sides relevant to short circuit. I hope you are getting me.
Yeah, I can get you, sir.
Yeah, in as much the fault is been rectified, or the clearing of the faults on the wiring is being done, and is this observed live and neutral of the inverter being having footage? What could cause that?
Okay, I need to understand it clearly. You said live and neutral having voltage on a testing driver, current tester.
Yeah.
Now, I will say this. For problems like that, when the inverter displays or when you use tester to test, even the body of the inverter, when the inverter is not connected to ground, when it's not earthed, and you use testing screwdriver on the body, it's going to show that there's power on the body. But immediately it is properly grounded, it will disappear. It's natural because the frequency, the topology of the inverter is what's making it to happen. We have high frequency running. All the transformers, they are high frequency. You know, so that high frequency alone will induce in the body. But once you earth it, it's going to disappear. And once that happens, there's no problem. Unless you now have voltage with your meter, that you have a voltage level, voltage difference that you can measure with your meter between neutral and air. And if that happens, that means the earthing is poor. But if the earthing is confirmed okay and that happens, then there could be a problem inside the inverter. And that is rare. It's not because for a problem to happen that you now have a voltage difference between between neutral and air, even when the earth is connected, then it must be a serious problem. It may be an open circuit or short circuit or whatsoever inside the inverter. But once everything is done, the earthing is done properly, every other thing is done properly, it should not happen at all. I think that answers the question.
Okay, thank you, Engineer Kunle. Total Logic, I believe you are okay with the answer. All right, good. I can see satisfied. So another person says, I noted Gennex inverters are majorly transformerless. Is there any reason? Are you looking at transformer-based inverter in the near future?
Okay, thank you very much for that question. We all know that the volume of inverter out there now that are transformerless is increasing. And transformerless inverter has come to stay. Transformer-based inverters may be cheap, but they have their disadvantages. Transformerless too have their disadvantages, but it can always get better. And is becoming so much very good these days. Because there is a lot of functions that you have in transformerless that you cannot achieve with transformer-based. And then looking at the capacity, because I'm just trying to state this because I don't see us going back to transformer-based inverters. Because there's a lot of engineering work going on transformerless, and they are getting results. So there's no way going back to say we want to be carrying that bulky iron. It's heavy. It's not easy for only one person to move around. One person can carry 2 units of 5 kVA or 5 kilowatt inverter in a bag, and you are good to go with it. Just carry it. You can carry on bike and everything. You can just move around. But if it is transformer based, only one that is 5 kVA, not to now talk of 10 kVA now, only one person cannot move it easily like that. So that alone is a problem. The repair of transformerless may be expensive because there is a lot of components in it. But then reliability is increasing every day. Now, they support medical equipment. If they are not reliable and tested, certified, they won't even start using transformerless inverter for medical equipment. They have checked them in terms of radiation, in terms of many things, and they are okay. That's why they are able to fit in. So transformer base is we are not going back to transformer base. I don't see us going back into it.
Okay, thank you, Engineer Kule. Are there other questions? Okay, so Engineer Kule, under the reduced output, you talked about the batteryless inverter. Please, for those of us that don't understand what it means, can you tell us what batteryless is and the advantage?
Okay. Batteryless inverter is inverter that functions directly from only solar or utility supply without battery at all. They process your solar energy straight into your load. They require a lot of solar panels to sustain the available load without any shutdown. Because if you have enough solar panels, you have a place to put solar panels, you connected all the panels well, you just, once it's connected, the inverter is good to go. You power it on and you put your load on it. But other inverters relies on batteries. If there's a shock in the load, like you power on a load that is heavy, the startup current will reflect on the battery to sustain that load. But for batteryless inverter, it will just start up from the solar. It's everything that it wants to do. The startup current of that load is from the solar panel. It doesn't really require battery. Even when you now connect battery, it still works fine without anything. It doesn't mean that because it's called batteryless, you cannot put battery there. No, you can connect batteries to it. Now, you can parallel them as well, but not in batteryless mode. If you want to do batteryless, you don't need to connect them in parallel. That is the specification from the manufacturer. But if it is just one inverter, then you can run it as batteryless, and it works perfectly.
Okay, thank you very much, Engineer Kule. So the last question here says, what makes a working inverter to change its delay time? So the person is saying that initially it changes with good, I don't know what this person, but with time, when there is power outage, the inverter takes more time to pick up. Hello, Engineer Kule? Hello? Okay, so while we wait for him, someone is asking which of the Gennex brand is batteryless? Does the batteryless really exist? If yes, how does it get integrated? So for the brands of Gennex battery inverters that are batteryless are 8 kVA twin, 6 kVA twin, MKS3, and also grow-watt inverter 5 kVA and 6 kVA. All these series are batteryless. Okay, is Engineer Kule back?
Yes, I think it's back. I think it's back.
Okay, welcome back, Engineer Kule. There is a last question for you before we call it a day. So what makes a working inverter to change its delay time?
Engineer Clear, you have the floor now. You have the floor.
Hello, Engineer Kule.
The inverter is transferring from utility to battery. So the only thing that I know that can affect delay time, because I need to know which part of what's that delay, which part of the system is the delay affecting. Because when inverter starts, it will delay a little bit when you are just powering in before it gives output. I don't know whether that's what it's talking about. Or transfer time. When utility arrives and then the inverter has to accept it in, or when utility is switched off and then the inverter needs to now switch to battery. So which part of it is delayed? If it is the going back to the battery, it could mean that the battery is low, because ordinarily the transfer time is fixed. But if the battery is low, it may drag a little bit because the battery is low before it accepts it, or eventually shut down on low battery or anything. That is that. But aside that, or the utility that is available is also low when it wants to transfer to utility while the battery is low, or that something is wrong, something is not working. If everything is okay, you have a full voltage from utility supply, and you have the battery that is healthy and is okay, and you have your appropriate load connected to it, I see no reason why there should be a delay in transfer. The delay is milliseconds. I think 10 milliseconds for transfer. And we now have inverters that don't even have that transfer time. Zero transfer, like MKS 0, then King. If for such application they may be required, they don't transfer at all. So it will just give you that 230. Even when your input voltage is 220, it will still condition that voltage to 230 and make it fixed.
Thank you, Engineer Kule. I think that wraps up this edition of the Gennex expose. But before we call it
hello, sorry, Brown. I don't know. There's a last question. I don't know if we can quickly take it.
Okay, all right. Let's take this question before. How can batteryless inverter sustain when there is no sun? Can it work perfectly in the night? Okay. All right, Engineer Kule, quickly answer this.
Engineer Kule, we are not able to hear you. I can see that you are talking.
Okay. I think there is another question, that how can a batteryless inverter sustain when there is no sun? It cannot work. No, batteryless inverter work with sun, the solar energy, and also with utility supply. So if you want to depend on only utility supply, well, then I think that's no more batteryless. You rather use your utility supply to power your load. Because if there is no sun, no solar energy, it cannot work. And using solar energy, you need to put the appropriate number of solar panels in place. If not, it's not still going to work. Because it will shut down if there's no, once the load supersedes the capacity of generated energy from the sun.
I believe the person that asked the question is cleared now. So thank you everyone for participating in this wonderful edition. But before we call it a day, I will let you know that this recording will be available after 24 hours on our YouTube. So if you are not a subscriber, kindly go to your YouTube and subscribe to Gennex channel so that you can see all these things. And apart from that, for those of you that have registered, you will see this slide on your email. And if you want us also to send it to you, there's a number display that you can copy and request for the slide. So for more about Gennex technologies, you can visit our shop. You want to get some products. And if you want to know more about Gennex, you can go to our website. And also, the academy training is coming up on the 31st of August. If you have never been part of this, I want you to join this edition that is coming up on the 31st of August. Kindly go to the chat inbox and copy the link, or visit our website as well. You will see it and the cost implication. Thank you everyone for participating. So we appreciate our Executive Director, Mrs. Toyinlo, for joining. We appreciate the facilitator, and I myself, the moderator, the host, and everybody that participated in this edition. Thank you and have a wonderful day. Yeah.